Good morning. Today we are going to see how the strength of the ligand molecule or ligand field will affect the values of crystal field stabilization energy. It has been found by experimental study of the spectra of the large number of complexes containing the different metal ions and many ligand molecules. The series is arranged according to the decreasing or increasing order of its crystal field stabilization energy, that is delta or CFSE. The variation of the magnitude of the CFSE with the nature of the ligand molecules follows a regular order, means they follow some regularity in increasing or decreasing the value. This series, when we arranged, that is called as spectrochemical series. The series which is arranged according to the increasing or decreasing order of its CFSE values is called as spectrochemical series. This series I have given as in the order of increasing value of their CFSE or delta. The first ion is iodide, I minus, has smaller value than Br minus, has the smaller value than sulfide ions, S double minus, have less value than chloride minus, then NO3 minus, then F minus, then OH minus, then oxalate ions, OX double minus, has less value than H2O, has less value than NCS thiocyanate ion minus, has less value than ammonia NH3, has less value than ethylene diamine, has less value than dipyridine, then NO2 minus, then Cn minus and Co. Means the higher value is for CO and Cn ligand molecules and the less value is for iodide, bromide and sulfide ions. I will repeat the series again. Less value for iodide minus, Br minus, S double minus, Cl minus, NO3 minus, F minus, OH minus, oxalate double minus, H2O, NCS minus, NH3, ethylene diamine, dipyridine, NO2 minus, Cn minus and Co. Means the ligands which are present at the left hand side, that is iodide, bromide, sulfide, chloride, NO3, are weak field ligands, means they have the less value, and the ligands which are present at the right hand side, that is CO, Cn minus, NO2 minus, dipyridine, ethylene diamine, are called as strong field ligands, means they have the higher values of CFSE. This idea of this series is that the d orbital splitting and hence the relative frequencies of visible absorption bands of two complexes containing the same metal ion but different ligands can be predicted. Means if the ligands are different around the same metal ions, it will changes the color, magnetic property, spectral property of the complexes. The this spectrochemical series is also useful to predict which are high spin complexes and low spin complexes. Now, what is the definition of this high spin and low spin complex? The metal complex which contains strong ligand molecule. I will repeat, the complex which contains the strong ligand molecules as Cn-CO, the pairing of electron will take place. Firstly, the pairing of electron will take place when they are accommodated in the d orbitals. Means gives the less number of unpaired electrons. Gives less number of unpaired electrons means what? They are low spin complexes. In short, strong ligand field, low spin complex. Opposite to this, when the metal complex contains the weak ligand molecules like water, iodide, bromide, the number of unpaired electrons is increased because pairing is not so done forcefully. Automatically, naturally, whatever the pairing is there, that can be done. Means it gives the maximum number of unpaired electrons. Means it is the high spin complex. In one sentence, strong field, low spin complex and weak field, high spin complex. And the effect of this field strength on the distribution of the electrons when present in the d orbitals and forms the metal complex will be discussed in the next week on possibly Zoom application. Okay, so see you.